All right, thank you. Well, thanks very much everyone for sticking around for the last talk. I apologize for my voice. Got a bit of the dreaded lurgy. See the red cordial's waiting, so we'll try and fire through this. But the talk that I'm giving you today, Common Pitfalls in Graphite Mineral Resource Estimates, was brought about by the concern of my and my colleagues seeing too much basics being left out of mineral resource estimates for graphite. So we'll talk about those common pitfalls, and the very first one is not applying the JORC code, no geological input to the domaining, and the other sad thing is that this is not just applicable to graphite. In fact, you can find this regularly across the mineral resource estimations that we see in the public domain. Inappropriate analysis methods, using unrepresentative densities, which, as you've heard, I've had a talk about density before, and it's one of the bugbears that we have. And inappropriate classification, which feeds into the JORC code. So just a quick reminder of what the JORC code is all about. The basic principles of the JORC code are transparency, materiality, and competence, which feeds then into your JORC compliant report. Obviously, we've got clause 20 that defines a mineral resource, and for graphite, what's of interest here is the quality, so grade or quality. And then clause 49, the important one for industrial minerals, specification. So specification is critical. So our first pitfall is when you see mineral resources reported with no petrography and no metallurgy, and where there's no reporting of specifications. So in our view, that is not a mineral resource. To understand the prospects for eventual economic extraction, you need information on the quality of the graphite, and that is the specification of the products. So really the specification comes down to recovery on the one side, but really your flake size distribution and your purity, they'll give you a basket price and allow you to determine a value for your project. Domaining is the next one, and putting the geology first sounds so blindingly obvious, but it is often not done. So we see this as a major pitfall where there's no geological interpretation done. And here I've just done a schematic sort of theoretical representation with some drill holes. Here on the left and right there's some structures with some movement on there. And you'll see that if you just used your grade to interpret the mineralization, those two yellow lines there, you'd get it completely wrong compared to the actual mineralization, which is the red zone. So really what it's about is using your geology. You need a solid understanding of the geology, the structural controls, the weathering domains, so that you can understand and correctly define your mineralization domains. Now, in graphite, obviously grade is always good, but quality is the most important thing. So in addition to your geological based domains, you've got to consider what the flakes are doing, or the graphite is doing within those domains. And here's just a number of pictures showing that I borrowed from Andrew, showing variation in graphite quality from some thin sections. And I just wanted to highlight here that you need to understand if the product or the quality of the graphite is going to be subject to significant spatial variability. So you can't just domain by grade. You need to understand the metallurgy. For that, obviously, petrography and metallurgy needs to be done. Now, another problem is incorrect weathering domain boundaries. And you'll see in that previous schematic there, we've got a base of complete oxidation and a top of fresh rock interpreted. It's very important because weathering is going to obviously affect the density and the processing and mining. In this image here, sort of on the top right-hand side, you'll see a sort of a darker brownish yellow material. That is your oxidized material. And this material is likely to be much easier to mine. It's probably free digging. But you could run into some trouble when you process it with some clays causing a few issues. And obviously as we come into the foreground of the picture here, you'll see some fresher material that you're going to have to drill and blast, but again you might not have issues with clays. So in order to define those weathering zones, we recommend the use of all available tools. Petrography, your assay results, particularly sulfur, can be very useful, and your drill logging, obviously, to define those weathering zones. And these slides here just demonstrate the difference in the mineralogy that you can get, how it can affect the graphite as well in the various weathering zones. This is just a bit of an aside. People often ask us what we recommend in terms of drilling for graphite projects, and we recommend diamond drilling. For accurate domaining, diamond drilling is much preferred because you're going to get so much more information out of your diamond core. You're going to get detailed geology, you're going to get your structural information, you can measure your density, you can get geotechnical data, undisturbed petrographic samples, and of course, good samples for metallurgical testing. On the other hand, RC is pretty much only going to give you a grade in general geology, and it's not much use for your petrographic and metallurgical testing. Now, density, the poor orphan child. One of the biggest issues that we find is that samples are not correctly prepared. For example, friable core is not sealed, and there's a variety of sealing methods, as you can see here, using wax, your spray lacquers, or even just vacuum packing. Obviously, the issue with density, when it's not representative, and here is a nice core tray showing the issue with representative that you can have when you want to representatively sample. What do you sample here? Well, I can tell you now that mostly the fieldy will grab a nice solid piece of core on the top left and leave all the rest behind. The issue is that your density feeds directly into your contained graphite. So you need to get the density right. And the other issue that we find with density is no quality control. So density must be treated like an assay. You need to have good quality control, use your standards, do proper quality control, and report it. When we come to analysis methods, inappropriate assay methods can be a problem. Loss of ignition, for example, is going to lead to overestimation of the graphitic carbon because of calcite and other hydrous minerals which contribute to the LOI. So obviously you're going to want to use your infrared detection, combustion. LICO is the machine that's commonly used. Those methods are going to give you an accurate total graphitic carbon. The other issue with assay is just good QA/QC. So if you have poor quality control, you're going to have a problem. So you need to use your CRMs, blanks, duplicates, and of course, umpire testing. And finally, we get to classification. And this is a big bugbear that we have, is that classification is often not appropriate. And I have borrowed this table from Jackie Coombs, who a lot of you will know. And really, it sort of summarizes the JORC table almost in one little, the JORC code in one little table here. And so you have your criteria down the left there, and increasing confidence in your resources, inferred, indicated, measured, going towards the right. And critically, quality of information there in the middle. When you're at inferred, you've got limited geological and sampling evidence. For indicated, you're starting to get adequate, detailed, and reliable geological and sampling evidence. Obviously, measured is detailed and reliable. But critically here, we get to the last line there, geological and grade or quality, which is obviously what we're interested for graphite, continuity between points. And you see, you start off with inferred, where you can imply initially, you can assume, and then you confirm with measured. But I go back to what I said right at the beginning. If you don't have any petrography and metallurgy, you can't even imply anything. All right, so the solutions, basically apply the JORC code. Read and understand the JORC code, apply it, especially clause 49. Domain using your geological and metallurgical properties as well as your grade. Use appropriate analysis methods. Make sure that your density is representative and representative by domain. Classify by the confidence in the geological and metallurgical continuity. Thank you very much.